Can you talk about Oklo and the possibility of there being other natural reactors on or off Earth? I would love to. In fact, I've published a paper on that very topic. Look right there. There's a reference for it. And let me give you the title, if you can also read right up there. The Ubiquity of Nuclear Fission Reactors Throughout Time and Space. How can nuclear fission reactors be ubiquitous throughout all time and space? That's crazy. Well, it happened at Oklo Gabon in Africa and possibly on Mars, as discussed in my paper. And it simply comes down to the fact that the fissile uranium-235 has a much shorter half-life than the fissionable uranium-238, which has a much longer half-life. Uranium-238 having a half-life of about 4.5 billion years. Uranium-235, the fissional component, having a half-life of about 700 million years. If you go back about 2 billion years, the uranium-235 with the short half-life, it grows exponentially in time. But about 2 billion years ago, it would have had a fractional component of about 5%. So the fissionable uranium-235 would have had about 5% natural abundance in uranium in the Earth. And that's the abundance that we have with actual regular nuclear fuel. About 5% uranium-235 is what we use for commercial nuclear fuel. And that existed naturally about 2 billion years ago. Now, if you'd gone back much further, say 4, 5, 6 billion years ago, maybe when it was first formed in some supernova, then it would have been much higher, potentially approaching not only high assay, low enriched uranium, but perhaps all the way up to high enriched uranium would have likely have been present at its initial formation. But the point is that by the time it goes through space and coalesces into an accretion disk and forms a planet, it is still right around there at about 5%, and just regular water potentially is enough to allow it to go critical, and that's what the evidence shows. And that's why it's a very strong argument for geological disposal of spent nuclear fuel, because Mother Nature did it. She made her own spent nuclear fuel, and she showed us how you stick it in the ground in a place where it's sufficiently stable that it just stays there. It's just a geological formation, and it decays down into dirt. It's just that when it becomes dirt, it's got a very different isotopic abundance of other dirt that you find elsewhere, but it's still just dirt, just a different kind of dirt with a different kind of mineralogy. So thanks for the question. I get to answer it with some of my own research. Have a good day. Bye.